Hello and welcome back. Today we're going to go ahead and add glad to our project. Now glad is just a way to render things to the screen, and if we do a CLI run real quick, what we've got is a window that can handle system events, but you can see we're not rendering anything to it. There's no calls being made to set a background color or to render any meshes or anything like that. So glad is gonna basically allow us to hit OpenGL calls on the back end, and we're going to use that instead of the SDL sort of renderer that's built in. So glad has a website here, glad.david.de. The I in David is a 1, and you can see that you sort of presented with a couple of options you get to pick, and then it'll just generate everything for you. So we want C++, OpenGL. Our GL version, we'll just pick the latest one. We'll want the core profile. We don't need compatibility. This is for like backwards compatibility stuff. We just want the latest and greatest. For extensions, there are certain things in here that sort of might be applicable to you given your system and your graphics card. If you don't know, OpenGL is really just a spec. It's a sort of please build things in these ways, and it's up to the graphics card manufacturers to implement them and to support them. For example, there's a debug output that actually helps a lot with debugging sort of OpenGL errors. Unfortunately, it's not available on some graphics cards. I actually don't know exactly which ones. But for example, like that's why these extensions, you sort of want to be careful with whether you pick them. I'm going to exclude them all. We'll just do everything with core OpenGL with no additional extensions. You click generate, and this will basically give you an include and a source, and it'll zip it up for you. So I've already downloaded this, so let's go ahead and download it, and we'll put it into our project. So here's glad.zip, and we're going to put it in our external folder, and we'll just create a new folder here called glad. And inside we'll just drag our include and source. And you can see our include, it's got glad and then KHR, and these are just 2 header files, and the source is glad.c. Now in order to build glad, so you can see we're sort of adding it directly into our project. It's not a lib that gets generated off to the side and that we like just build once. We're actually going to be building this every time with our project. So we're going to need a premix 5.lua. So we can actually add one here. And I'll probably just open with code just at the root level. And similar to our base sort of premix 5.lua, we're going to have just a project definition for glad. So I'm just going to copy this. We won't need this many filters either, but I'll just copy it, and I'll create a new premix 5.lua here, and I'll just paste it. And then I'll just update it in line. So this is now the glad project. We don't need a location because it is at the root level, like it's here, include and source. The language is actually C, not C++. It is still a static lib. Basically, we're going to build this as a library, just like we do Hippo every time. We don't need the dialect because it's C language. Static runtime will have on, and then our target dir and our object dir will remain as is. You can see that I'm referencing tdir and odir, and they're not defined here, and that's fine. That's because we're going to actually include this premix 5.lua file from our base one, and we'll do that in a bit. So the files, we know they live in the include directory and the source directory. This include this will ensure that we do both the glad and the KHR includes, and then source we'll just want to do .c instead of .h or .cpp. For our includers, we're just going to include itself and nothing else. We don't want any flags for glad. We'll just let it build the way we got the code from that generator. And you can see we're not defining configurations here. We don't really care. Again, I think I mentioned this before. You can put the star. You can just exclude it, and it'll just excluding it will mean it'll just do this for all configurations. And we'll keep system version latest, and that's all we need. We don't need any additional defines here. For Mac OS X, again, we'll just remove this. We'll keep the build settings. These will just keep them to match what we're using it for Hippo. And again, no defines. And for Linux, we actually weren't doing anything special for Linux, so we don't need anything else. We don't need any defines. For our debug and release configurations, again, we don't need to define anything here. We'll just have runtime debug symbols on. And for release, we'll just have runtime release symbols off, optimize on. And again, I think symbols off is the default. It doesn't really hurt to have it, but that's fine. And that's it. So that's all we're doing here. We're just defining this project. You can see that was pretty straightforward. Now in our main premix5.lua, we're going to come up and add glad, right? So we'll add new externals, glad, external slash glad. And then we want to make sure that we process glad before anything else. So process glad before anything else. And you do this again with an include, and then you'll include external slash glad. And what you're doing here is you're saying, go look in this directory and find any other premix5.lua files and actually execute them. So you can see we're going to run that project and before we run the hippo and hippo editor projects. Good. Now in the includers, we'll add glad. And then we want to add a define. Basically, glad by default will try and include glfw. glfw is another windowing sort of input library that you can use. We're using SDL, so we don't want glad to do anything with glfw, so we have to tell it so. The way we do that is with a define, and you can see I have defines per platform, but this will be an all-encompassing define. It doesn't matter what platform or configuration we're in. So I'm going to add a define section here, and this block will just be sort of defines regardless of the platform or configuration. And the define itself is glfw underscore include underscore none. And I'll just ensure glad doesn't include glfw. Otherwise, it'll fail to compile. Okay, so that's all we need. Again, because glad is happening first, we know we'll have a lib that we can refer to, and we'll sort of link to it in our hippo editor project, just like we do with SDL. So just going through SDL2 will now also link to glad. And this again will give us the ability to make OpenGL calls in each platform. So I'll save that. Let's just go ahead and regen SLN, make sure everything's good. Yep, that's good. So you can see for hippo solution, external glad, it did that first, then the hippo lib, and then the hippo editor. And you can see it looked like everything's fine. So let's just build this LN real quick. Even though if we're not including it, I don't think it builds anything, and I don't think it is, but that's fine. We'll do that next. You see now it's linking to glad. Oh, it is. Okay, cool. So yeah, link to glad. It looks like everything's happy. So switching back here, of course, we just gen SLN, so let's reload that. And you should see now we have a glad project. So we have 3 projects now: glad, hippo, and hippo editor. And glad, again, we didn't, oops. Glad, as you can see, it now has a bin and bin obj. All of this still sort of encompasses what we've defined. We have a glad.lib, and that's what we're including, and that's what we're linking to. And then in glad, in the include and source, these are just the files that we got from that generator, and here's our premix5. Okay, so now that we have glad, let's go ahead and include it. So right now we have an SDL window. When we want to use OpenGL within SDL, we need to capture the OpenGL context ourselves. So we'll have to forward declare the type itself. It's SDL underscore GL context. But if you look at it, you can see it's just a type def for a void star. So you can't actually forward declare that. So instead, we'll just have a using equals void star. I don't mind copying the fact that it's a void star here, simply because I know that's not going to change on the SDL side. So this is sort of equivalent to a forward declare, in which it'll actually allow us to define this up ahead here. So we'll now have an SDL window star and an SDL GL context, and it's already a void star, so we don't need to add a star here. And we'll call it MGL context. And then switching to window.cpp, we're now also going to include glad/glad.h. And here's where we can actually start making OpenGL calls. In window.create, once we know we're good, we're going to go ahead and do that piece. So first we have to define a couple of attributes for OpenGL, and like the version, the stencil size, whether we're double buffering or not, which we want. And then on Apple specifically, we need to define something else. It's a forward compatible flag. So we'll just go through those now. So ifdef hippo platform Mac. We'll call this SDL underscore GL underscore set attribute method. And we're setting the SDL GL context flags. And we're setting it to SDL GL context forward compatible flag. And you need this because Apple specifically has sort of stopped really supporting any version past 4.1 for OpenGL. And if you don't have this, I've just noticed that it'll give you some errors sort of when you try to load the app. So we'll do that, and then we'll set a couple other attributes. So for all platforms now, SDL/GL context, the profile mask. So we want to tell it which profile we want to use, and we want to use the core profile. So SDL/GL context profile core. Okay. We also want to give it a major version, and will be 4, and a minor version 1. So we're using OpenGL 4.1. I know we downloaded it up to 4.6, and if we did want to sort of drop support for Apple, we could. We don't have to deal with it anymore, and then we can bump it up and use some of the new stuff from OpenGL since 4.1. But for now, since we want to target all platforms, we'll just keep it at 4.1. We also want to ensure that we are using double buffering. If you're not familiar with double buffering, you can probably look it up. It ensures that all the draw calls happen to a back buffer, and then we tell OpenGL to flip the buffers. And this helps you with sort of flickering on the screen if you're trying to render and draw to something at the same time. So setting it to 1 turns it on. That's all we need for now. Additionally, we can set a couple other things like, I don't know, minimum size for the windows. So SDL set window minimum size. We'll just do 200 by 200, just because we can. And sort of now that we've done all the attributes, we can actually create that OpenGL context for us to hold on to. So MGL context equals SDL/GL create context, and we'll give it the window. And now we have to check if MGL context does not it is null pointer. Then we'll throw an error. And now that we know we have a valid context, we can call a glad method called glad load GL loader. SDL/GL get proc address. And this, it takes the load proc, it's a function pointer. We're not calling this function, we want to just tell it the name of the function. And semicolon. And this line, basically what it does, we can Alt-G into it and just see. You'll basically see we're going through with that sort of function pointer that we're passing in, and we're loading OpenGL for all of these versions. You can see it actually loads 4.6 even though we're not using it at runtime, and that's fine. And internally what this is doing is it's just mapping these function pointers, like these are function pointers that map to a call that it makes on your graphics card. And the reason we like to use GLAD is because it does all this for you. It supports all the GL function calls, and it just maps them to whatever your graphics card's version of that is. So thank you, GLAD. This is very useful. We don't have to look at this code. We just know that it's going to work. Let's run that. We shouldn't see any changes, but we also shouldn't see any issues or crashes or errors. And we do. And that's one more thing we forgot to do. We couldn't create an OpenGL context because we haven't told SDL that we want to do so. We have to tell SDL. We've set everything up, but we haven't told it that this window will be an OpenGL window. And you do that with a flag. SDL window OpenGL. This, by the way, I'm not really happy with right now. Really what we should be doing is passing in a Windows property object that has this stuff internally, and we can just sort of reference it here. We can sort of fix that up later. But by passing this in, SDL will now know that this window is meant to be driven by OpenGL. If we try to run this now, we should see our normal window. And we do. This disappeared again, but it's there. And you can see the window's still good. We set a minimum size and we can't resize it, so we can add that as well. That's just another flag. So you just use the OR to bitwise OR these flags together. SDL window resizable. If we run that now, you can see that I can resize the window, and yes, you'll see this. SDL does not re-render while you're dragging this. Once you let go, it will re-render. Now on top of that, we are not rendering anything, so it just sort of breaks a little bit, but we will fix that very soon. And you can see I should only be able to go down to a perfect square here minus the title bar of 200 by 200 pixels. Perfect. So now we have the ability to make an OpenGL call, so let's go ahead and actually call something. So we want to render something and then sort of swap the buffers so that we can see that. And the way we're going to do that is the window, we'll just have it support a begin render and end render method. Because really, most of the rendering isn't going to happen in the window class, but we do need the window, who owns the OpenGL context, to set the clear color, actually render that clear color, and then to swap the buffers at the end. So our engine will basically wrap these calls, and then it will call out to the game to render whatever it wants to in between these calls. So we'll have these two methods, and let's go ahead and implement them. And the first thing we're going to do, again, we have access to GLAD, which means we have got access to all of the OpenGL calls. So GL clear is an OpenGL call that clears sort of clears the screen. And you want to tell it what to clear. So we want to clear the color buffer and the depth buffer. So GL color buffer bit. This is just saying clear the color of the screen. And we also want to bitwise order that with GL depth buffer, which means clear any cached information about the depth of what you've rendered. Now, we haven't dealt with depth yet, obviously. We haven't even enabled it yet, so maybe we'll do that. But really what this is going to do is clear the screen with the color that we've told it to clear to, and clear the depth buffer so that the next time we start rendering things, they're properly sorted in the depth ordering. And again, this will be used just sort of to know what's being rendered in front of or behind what else. In end render, we'll call SDLGL swap window. Pass in the window, and this is going to swap those buffers. So even if we call GL clear and render a whole bunch of stuff, if we don't call this, we'll never see it, because we told it explicitly to double buffer our calls. Now up here, we can actually, now that we've loaded GLAD, we can have some OpenGL initialization code. This really should be like part of our renderer, which we will get to probably next video. But for now, we'll put it here. We'll just have to move this to a renderer initialization. So what we're going to do is enable GL depth test. So we will enable the depth test, which it will allow us to internally will allow OpenGL to skip rendering things that are behind other things, basically. And we need to tell it sort of what that depth test function is. So GL depth func will be GL less than or equal to. So you can definitely look this up for more information. I won't get into the specifics here, but just thinking about it, if we have something at Z position 0 and then something at Z position 1, and let's assume 1 means further away, we won't render any part of the second object that sits behind the first one, mainly because the first one is closer to the camera. Additionally, we'll enable GL blend. This will allow us to blend things together if there's any alpha. So if I have a semi-transparent object in the front and something behind it, we should be able to partially see through that object. This will let us do that. And again, we'll have to give it a blend function. So GL blend func, and we'll use GL source alpha, GL1 minus source alpha. Not source 1 alpha, source alpha. And again, this just does exactly what I said. I don't blend things together if there's any sort of semi-transparent objects. Finally, we can actually tell OpenGL what we want the clear color to be. So when we call GL clear color buffer bit, what color should it clear the screen to? For now, let's just make it red. 255, so this is 0 to 255. This is red, green, blue, and alpha. Okay, so now that we've set this up and we have a begin and end render, we just need our engine to call these on our window when it's rendering. So we have a core loop up here, and all we're doing is pumping the events. Let's just go ahead and say in window.begin render and window.end render. We will have to pull this out into a proper render method that maybe doesn't get called as quite as often as our update method, and you know, again, we'll get to that, but this is sort of the idea where we can begin render, end render, and somewhere in the middle we would actually render our scene with our objects and everything. But at least now we should actually be rendering something red to the screen. And you can see that we are. So even as we're sort of resizing this, you can see this is what I was mentioning again. It's not re-rendering anything, but as soon as I let go, it'll keep rendering, and it'll properly sort of clear the buffer and with the color that we've defined. Now, I know I just said this is 0 to 255. It's actually 0 to 1. 255 comes from some other API. If we can test it, if we just do 1001 These should be floats. Yeah, you can see right here. They're floats, so they're meant to be a value between 0 and 1. 0 meaning no red, 1 meaning all red. Same with the blue and the green. And obviously we'll blend that sort of internally. Now, this is great. This is basically OpenGL setup. We're able to start rendering things and sort of abstracting these render calls. We probably wouldn't want to have like actual GL code like on, I don't know, a sprite object, for example. We'd want all that stuff to be abstracted to a renderer. So we'll do that next. But I don't want to end the video without changing the background color to something that's very comforting for me. I don't know if any of you have worked with XNA in the past. It was Microsoft's sort of game framework back in the day, which is no longer supported. There are other versions of it. Anyways, it used a background color called Cornflower Blue, and I'm really, really fond of that color, so I will do that here. It's 6495 ED. It should be a very comforting light blue. It's called Cornflower Blue. Yeah, there it is. So there we go. We have OpenGL set up. That wasn't too hard, thanks to Glad, because it does all the heavy lifting for us, and just by calling one method, we have access to all of the calls, and you can see they're just macros that it is handling for us here. I opened the GLES version, but it does it all internally, so that's wonderful. So this is a great place to leave this video because it will allow us to build out a full-blown renderer next video. And really what that's going to look like is it's a renderer with some render commands that we can either queue or sort of immediately fire. And we'll be able to sort of define what our rendering pipeline looks like now that we've got the ability to call OpenGL directly. So that's it for today. Thanks for watching.